Today we are covering feed-forward networks inside transformers, where each token gets nonlinear computation after attention. The goal is not to memorize a slogan. The goal is to build an interview-ready explanation that moves from intuition, to mechanics, to trade-offs, and then to a concrete example. Intuition. Attention mixes information across tokens. The feed-forward network then processes each token independently, expanding and compressing its representation with nonlinear layers. If you remember only one thing, remember the shape of the problem. Raw information is transformed into a representation that makes the next decision easier. Core mechanics. FFNs are applied position-wise to each token. They usually expand hidden dimension, apply activation, then project back. They add nonlinear feature transformation after attention mixing. The same FFN weights are shared across positions in many LLMs. FFNs contain a large fraction of parameters. The compact mental model is FFN x equals W2 activation, WX plus B2. Do not rush past the symbols. In an interview, define each part in plain language before you talk about implementation. That makes you sound like you understand the system, not like you only memorized notation. Common traps. Do not confuse FFNs with attention. FFNs do not mix tokens directly. The expansion ratio affects parameter count and compute activation. Choice matters. GELU, CLU, or gated variance. FFNs can dominate memory and latency in large models. Concrete example. After attention gathers context for the token bank, the FFN can help transform that context into features closer to river bank or financial bank depending on the sentence. Walk through the example slowly. Say what changes at each step, what stays fixed, and why the operation helps the model produce a better representation. Interview checklist. Say attention mixes tokens, FFN transforms each token. Write the two-layer structure. Mention expansion dimension. Name common activations. Connect FFNs to parameter count. A strong final answer for feed-forward networks inside transformers should have 4 beats. First, give the intuition. Second, name the components. Third, describe the formula or data flow. Fourth, mention the trade-off. If you can add one example, you will usually sound much more practical than someone who only gives a textbook definition. Now let us rehearse the answer in a more conversational way. Start broad. What problem are we solving, and why did this idea become useful in modern AI systems? Then narrow down, what data structure or tensor is being manipulated? Then explain the operation, what is multiplied, normalized, added, masked, or learned. Finally, connect it to behavior, faster training, better context, more stable gradients, lower memory cost, or clearer generalization. For interview practice, avoid 3 mistakes. Do not give only math without intuition. Do not give only intuition without naming the mechanism. And do not pretend there is no trade-off. Most AI interview questions are really trade-off questions wearing a concept label. The best answer shows you know when the method works, when it becomes expensive, and how engineers usually manage that cost. Quick recap: feed-forward networks inside transformers, where each token gets nonlinear computation after attention. Use the mental model, define the pieces, give the example, and close with the practical trade-off. That is the answer structure to keep in your head. One more interview rehearsal. Explain it as if teaching a teammate. Define the input, describe the transformation, name the output, and close with why the design choice matters in real systems. This habit turns a memorized answer into a practical engineering answer.